We hear it all the time. The green energy transition is about political will, it's about innovation. But what if the biggest roadblock isn't some policy debate? What if it's something physical, something hiding right under our noses? Let's get into it.
Now that is a bold statement. I know, it sounds crazy, right? But when you really start to crunch the numbers, the math, well, it just isn't mathing right now. It seems our biggest, most ambitious climate goals are about to hit a brick wall.
And the craziest part? The thing causing this massive problem isn't some super rare, exotic material from a sci-fi movie. Nope, it's a metal we've been using for thousands of years. Copper. It's so common, so everyday, we don't even think about it. But it's shaping up to be the Achilles heel of our green future.
Just think of copper as the circulatory system of our entire electric world. Its ability to conduct electricity is amazing, second only to silver, which makes it absolutely essential for, well, everything. Wires, motors, circuit boards, you name it. Without copper, electricity just doesn't flow. Simple as that.
Okay, so you're probably thinking, copper's been around forever, right? Why is it suddenly this huge deal? Because our green future is absolutely starving for it. And the hunger for it in our new tech versus the old, it's just off the charts. I mean, just look at this comparison. It's wild. Your standard gas-powered car has, maybe 50 pounds of copper in it, max? But a fully electric vehicle? It needs around 183 pounds for its motor, its battery, all that wiring. Now, multiply that by the millions and millions of EVs we plan to put on the road, and you start to see the scale of this thing. And it's not just cars, not by a long shot. A single, big offshore wind turbine, we're talking up to 15 tons of copper inside. Its generator, cables, transformers, 15 tons in just one turbine. And this hunger for copper, it's absolutely everywhere. Onshore wind, solar farms, and the massive, massive upgrades we need for our smart grids, it all adds up to this crazy, unprecedented demand. So the obvious question is, why not just mine more, right? If we need it, let's just go get it. Well, this is where the plot thickens. This is where the demand crisis slams right into a really complex and challenging supply crisis. See, the issue isn't really that the copper isn't in the ground. It's the whole messy business of getting it out of the ground and to where it needs to go. And there are some serious roadblocks every step of the way. And here's maybe the biggest bottleneck of all, time. You can't just open a new mine. From the moment you find a deposit to the day you actually start producing copper, you're looking at a 10 to 20-year journey. All the studies, the permits, the construction, you just can't fast-track it. And to make things even trickier, the easy-to-get copper, that's pretty much gone. The high-grade stuff has been mined out. So today, companies are literally moving mountains of rock, using way more energy and water, all to get a tiny percentage of actual copper, often less than 0.5%. Then you've got the geopolitical angle. Think about it. More than a third of all the world's copper comes from just two countries, Chile and Peru. That means one political crisis there, one major strike, one natural disaster, and the whole world feels it immediately. And the list just keeps going, really. For decades, there hasn't been enough investment in finding new mines. The places with the most copper, like Chile, are facing critical water shortages. We don't even have enough facilities to refine the raw ore. It's like a perfect storm of supply problems, all converging at the worst possible time. So, okay, we've got this insane, unstoppable demand on one side and this massive supply squeeze on the other. What happens when they crash into each other? Well, the consequences for our green energy ambitions are pretty dire. The projections are, they're pretty sobering. By 2035, the world is going to need about 50 million metric tons of copper a year to even try to hit our climate goals. But even with the most optimistic forecasts, our supply is probably going to top out somewhere around 30, maybe 35 million tons. I mean, that's not a gap, that's a chasm.
We're talking about a potential shortfall of 15 to 20 million tons every single year. To put that into perspective, that's almost as much as the top two producing countries, Chile and Peru, pull out of the ground combined. A shortfall that big basically makes our current climate timelines, impossible.
And a shortage like that kicks off this really dangerous domino effect. Prices for everything green, EVs, wind turbines, solar panels, would go through the roof. The energy transition itself would slow to a crawl. You'd see nations scrambling and fighting over resources, which could spark all kinds of economic instability. It's a bad scene. Okay, so that's a pretty grim picture, I know. But it's not game over. A crisis this huge doesn't have a simple answer, but it does have answers. So, what do we do? How do we start to fix this? Yeah, there's no magic wand for this one. There's no single solution. It really means we have to come at this from all sides, all at once. We need smarter, more efficient mining technology. We absolutely have to get better at recycling. We have to pour money into researching alternative materials, and all of it needs to be backed up by smart global policies. A huge piece of this puzzle, especially for the long term, is this idea of a circular economy. Instead of our current take, make, throw away model, we've got to get way, way better at recovering all the copper that's already in our old gadgets and buildings. It's something people are calling urban mining. Right now, we only get back about a third of it. Just think about what a difference it would make if we could double that.
But even if we get all the tech and all the policy right, this crisis forces us to ask a much deeper question. It's not just about getting more metal, it's about how we go about getting it.
And this is where things get really tough. We have to look the ethical challenges right in the eye. Any new mining has to be done in a way that protects the environment and respects the rights of the communities who live there. We can't build a so-called green future on the back of environmental destruction or human rights issues. The goal can't just be green. It has to be just.
So in the end, this isn't just an engineering problem. Solving the copper crisis is going to take so much more. It's going to demand foresight, a real sense of ethical responsibility, and countries actually working together.
And that really leaves us with the big final question. This whole copper crisis, it's a huge wake-up call. It's forcing us to ask ourselves, can we actually power our clean energy future without making the same old mistakes? Can we do it in a way that's truly sustainable, from the mine all the way to the windmill? And the answer to that question, well, that's going to define the kind of future we're actually building.